Okay, hey y'all. So I got this question. It says a 20-gram sample of some sort of element, we don't know what it is, it's going to be one of those, contains 1.37 times 10 to the 23rd atoms. And then it asks what the sample is. All right, so we're going to look at these things. If we look on the periodic table, radium, helium, etc., they differ by the number of protons, but they also differ by something else, and that's the molar mass of these things, or also known as the atomic mass. So, for example, helium has a molar mass of 4.00. Tellurium has a mass of 127.60. So they all have different masses. And those masses, if you think about it, have units of mass, which is in grams per mole. Okay? The molar mass of something is in the grams per mole. We know how many grams we have. It's 20 grams of a sample. If we can figure out how many mole this is, we can just take the grams and divide it by the mole. So in other words, we're going to say, hey, we know 20.0 grams divided by some number of mole. And then that will give us our molar mass, and therefore we'll be able to decipher which of these it is. So when we go to do that, though, it's important to remember how to take atoms and turn it into mole. So if you remember, we went from grams to mole to molecule to atom, and we can also go back, right? And we said to go from grams to mole, you need the molar mass. To go from mole to molecule, we need 6.022 times 10 to the 23rd molecule per mole. And to go from molecule to atom, we needed the number of atoms in a molecule. Well, when you're talking about just one thing, these aren't really technically molecules, they're just atoms. So this right here will end up being one. There's just one atom of radium and a molecule of radium. So there's just one atom in it. So, but let's go ahead and do it. I think if we get started, it'll make it a little better. So we're going to start with atoms. We're going to work our way all the way to mole. Again, if we figure out mole, we can plug it in there and solve for our molar mass. All right, so starting with atoms, we got 1.37 times 10 to the 23rd atoms. Okay. Then if this is atoms, we know atoms has to go here. Again, there's just one. We're not. It's not like remember when we talked about in class, it's NaCl. That has two, right? Atoms in one single formula unit or molecule. Here, there's just one thing. So there's one atom in a molecule. So you could have just skipped that part and started here. Now we're in molecule town. If that's molecule, we know molecule must go here. And then mole has to be resulting on top. Oh, and I don't know why I continued on. We're done. We made it all the way to mole town. Good job. So molecules cancel, atoms canceled. We're left with mole. To solve this, just to remind you how the math goes, everything on the top is multiplied, everything on the bottom is divided. So that's multiplied. The bottom, we have a 6.022 on the bottom, and we have a 10 to the 23rd on the bottom. So both of those get a division sign. Now, when you have a times 10 to the 23rd and a divided by 10 to the 23rd, those should actually cancel. But let's do it anyways, just for the practice, in case you want to see it. 1.37 times 10 to the 23rd divided by 6.022 divided by 10 to the 23rd. Let me do it one more time. 1.37 times 10 23rd divided by 6.022 divided by 10 to the 23rd. And I get an answer of 0.227499. Okay. I could have put 50. The reason I kept all these numbers, we have 3 sig figs, which will result. And then I want to keep some extra numbers. Again, I could have put a 50 here. Okay, so this gives us the total number of atoms. All right, to remind you again, now to get the molar mass, we take grams and divide it by the moles. So molar mass is going to be 20.0 grams divided by the answer we just got, 0.227499 with 3 sig figs. And I get an answer of 87.9 grams per mole. So we go over here to the periodic table and we see which of these molar masses best fits what we just came across. So, so helium again was the 4. Radium is, where are you, radium? Right here, it's like way off. It's like 220 something. Tellurium, I think, was 100 something, 127. And then there's strontium right here, which comes out to 87.6. I don't see it. There it is. 87.6. So that is definitely the closest one, and that's why the sample that you had must therefore be strontium. All right, I hope that helped, and good luck.